welcome back, welcome back. We just completed P5 and M3 where we had to develop the entire system, make sure everything worked. M3 said develop a functional prototype IoT system or device to solve a problem as intended that meets the client's requirements. Don't touch this section here yet. Reason being, once you've developed it and it works to some degree, you've already met the criteria for M3. And don't mention anything about the client's requirements yet, because on the P6, I believe, yeah, P6 and D2 is where we actually need to speak about that stuff. So for P6, which is what we're going to be doing now, review the extent to which the IoT system or device meets the client's requirements. We had the list of requirements from the very beginning. The client wanted X, Y, and Z. Make a bullet pointed list of it and just ensure that you can say you've done everything. So review the extent to which it does it. So before you even get the person review one here, which is what I've done, I would go back and I would say requirements, or say OG or original requirements. And on the original requirements, I'll probably just do a table, insert table, and list all the things that needed to be done. So maybe detect movement or entry when whatever was this done. Actually, let's put over here completed or not. And over here, let's label this section requirement, requirement. Paste this there. Was this completed? Yes, completed. Perfect. The next thing, and this is how I would do it. So review the extent to which the IoT system meets the client's requirements. If you're reviewing something to meet client's requirements, what were the requirements originally? These were the requirements. Detect movement, yes. Sound buzzer, yes. Flash LEDs, that was definitely done as well, yes. Notify, actually, let's make it a bit more detailed. Send email, yes. Send text message, yes. What else did the system need to do again? Always be on, yes. And that's pretty much all I think you need to do for this. Reason being, we're going to join this section with a review from other people as well. So down here, it says person one review. You're going to have your peers reviewed. So have someone run the program, have someone look at the system to see what you've done, and have them give you a review, just like we did for the previous review. The only difference here is that we don't have multiple things. For the previous review, we had pseudocode, we had flowchart, we had sketches, we had all these different things that we can review, or we could have reviewed. For this section, we only have one thing, which is the working system, the code. That's it. So have person one give you a few comments, have person two give you a few comments as well, and person three, or it could be you. I think you only need to do two, but I always do one more than the necessary than the minimum requirement. And here you have your own review as well. And just like before, whatever comments they've said, so person one might actually say, I think I did leave out something. You left out the switch to turn the system on and off. That's a perfectly valid thing. So I'm going to copy this. Whatever comments you get from all of them, copy every single comment into that mini table underneath. And if you agree, say agree. If you disagree, say disagree. I agree with this one, meaning I am going to go back and fix this. Let's say I disagree with the code is the circuit is a bit messy. This is not important. It's a prototype. It doesn't need to be great. It works, and that's the main thing. The circuit is a bit messy. Even though this person is correct, because you're not going to do this thing, you put this, agree, leave it there. That's it. And you fill this in with as many comments as you get. So if you get 3 comments from this person, you put the 3 comments in there. If you get 2 from this person, you put 2 in there. If you get 10 from person 3, put 10 in there. The only thing you don't do is if they overlap. So if person 3 comes and then says the circuit could be a bit more neat, be like, okay, that's the same thing as the circuit is a bit messy. So you don't need to say that twice, right? That's it. Once you have your things that you're going to do, for me, the things that I know that I want to do, again, I might as well put one on the own review. The thing I needed to do was to fix Python file from only running once, which means I need to fix that function thing I mentioned earlier where I put all of that file contents in a function and maybe call the function instead. This is a fix for me, right? You might as well copy it here as well. Do I agree with this? Perfect. So now I have the things I'm going to work on for the optimized version of this. To optimize something simply means to make it better, to make it run faster, to make it do more than it's currently doing. That's what optimize means, generally speaking. And that one is actually going to be D, to evaluate and optimize IoT system or device to solve a blah, 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 using feedback from others. So this is the part that we've just done. Feedback from others. Your feedback isn't necessarily important or relevant, but why not? You might have noticed something with the system. Don't fix it as soon as you notice it until you get to this section. Weirdly enough, because if you fix it before, you don't have any review from anyone else, but you say you fixed it, you actually don't get the marks because you haven't shown that you've gotten feedback and you've then actioned something based on the feedback. So this is the feedback section here. Person 1, person 2, person 3, and own review. Implementation improvements. This is where you're going to list every single comment that was given to you by your peers or by anyone else who checked it. You're going to either agree or disagree. If you agree, those are the things you go back and fix. So for me now, I know I need to go back and I need to add the switch. So things to action, maybe that's the thing you should add, things to action. I'm going to put add switch. It's to be ITCH, and that's one thing. And the other thing is fix file calling another file. That's it. And now when I go in and do this, which is what I'm going to do now, I'm going to try and add the switch so that when the person flicks the switch, the system is completely off. When the person flicks the switch, the other way to make it go on, it's on and the system is running as it should. Then I'm also going to fix the Python file as well. So I have been doing a few tests and my theory, I believe, was correct. So I have file A, file B, and file C. File B and C, I'm essentially going to put these into functions in file A and then call them later on. So for example, I have a function called file B, and inside file B, I can put all the stuff I want to do. I have another function called file C, and in here I can put all the stuff I want to do, even the import stuff as well. And finally, in file A itself, all file A has is this stuff here. So when I run it, so I say for I in range 5, so this should run 5 or 6 times. I don't remember how this works exactly. It's going to print this is from file A. Let me remove that one there. And then it's going to go to file B, run the file B function, then run the file C function. So let me run this and see exactly what happens. My Raspberry Pi Pico is still plugged in, so this should work fine. File ABC, perfect. File ABC, perfect. File ABC, 5, 6, yeah. Roughly about 5 or 6 times, yeah. So this seems like it should work. So the reason I showed you this, just to explain how it's going to work for the final system. So mine is called full system here. And on the full system, I'm going to need to go and get these files and put them in a function at the very top of my program. So 013 send email. So I'm going to go to 013 send email. And all I'm going to do, I'm going to copy every single thing from here. Control A, Control C to copy everything. And again, Control A highlights everything. And then Control C copies everything, or I can right click and do copy. I'm going to go back to my full system. And at the very top of my program, just before I have the while loop, I'm going to put function and I'm going to call this one send email. Was it send email? Yeah. So define send email, open, close. There we go. Let's move this down a bit so it's very obvious where one thing starts and stops. Paste that all in there. And now the thing I need to do with this, I need to indent this with a tab so that it knows it's inside that function. So highlight everything I just pasted, everything in here, and I need to tab this one over like so, and that should be good. Then I'm going to come down here and do exactly the same thing for send text message. So 015 send text message. So let's close that one first. I'm now in my 015 send text message. So again, I'm going to copy all of this. Control A to highlight, Control C to copy. I'm going to go back to my full system, go to the very top again. I can do this one anywhere. So I'm going to do this function under the previous one. And I'm going to call this one define send text, open, close, colon, paste it there. And again, I'm going to highlight everything that needs to be inside this function. And then I'm simply going to indent it once by pressing tab on my keyboard. That should shift everything over once to where it needs to be. That's it. So now I have my two functions inside the same file. This should work, fingers crossed. So one is called send text and the other one is called send email. I'm going to scroll all the way down again to my normal stuff that works. And where I have send email, I'm going to remove this and I'm going to just simply call the function I just created. In this case, it's send, and I'm going to do email first. The next one is send a text message, so I'm going to get rid of that as well. SEND. If you want to get the autocomplete option, press Control, hold it down, and press space on your keyboard. So that one is send mail, this one is send text, and this should work. Fingers crossed this works. If this doesn't work, then I'm going to leave it and just move on to everything else. All right, so again, this is my entire thing here. This is the same thing I had earlier. The only difference is I have functions at the top with all the stuff I need to send an email and all the stuff I need to send a text message. So let me just quickly press play now and see what happens. Is my system plugged in? Yes, everything is plugged in and okay. Press play. No motion, no motion, no motion. All right, let's see if that's going to change when I move. Yep, that changes. LED's on. Yep, it's connecting. It's connecting perfectly okay. Sending message with Twilio. Perfect. Text message sent. Perfect. Motion detected again. So yeah, I just heard my phone vibrate, so I definitely got that text message, and I'm making the assumption I got the email as well. The email would have been a lot quicker because it's a lot quicker to connect to that service. And text message sent. Yeah, so this looks like it will keep going back and forth. Yep, it's connecting again because motion was detected. Yeah, so I'm going to stop this before it eats all my free text messages I get with Twilio. This now works. So this system fully works. It's not very well optimized. However, it is optimized because it is better than it was before. Everything works as it should. The only thing I probably don't have is the switch. At this stage, I might do the switch at some point, but I'm going to leave it for now just to get the rest of the criteria finished. The switch is going to be really simple. What you have to do for the switch, you would have to put the switch at the top of the while true loop. So you could say while true, something along the lines of if switch equals 0, you're just going to go back. So return to the main part of the function and do nothing and keep checking if the switch is 0. However, you can say else, and then everything that you have under here would go inside that else statement. So if it's 0, it does nothing. If it's a 1, this is essentially checking if it's a 1 because it can only be 0 and 1. If it's a 1, do all of this stuff here. So if the switch is on, work. If the switch is not on, do not work. All right, I might do that at some point as I mentioned, but for now I'm going to leave it and move on to the other criteria. After you've done the optimization, the last thing you need to do is simply to come back here under your implementation improvement section. So this table here, come back and simply paste the new code that you've written in here and explain what was changed and explain why it was changed. That's it. This section is completely finished.